Hey, Math 110 students, I forgot to give you a keyword in the last video, so I'm going to open up this one with the keyword, which is Descartes. D-E-S-C-A-R-T-E-S, not Descartes, but Descartes, who is a Frenchman who came up with Descartes' rules of signs. He's also the guy that came up with Descartes' Cartesian plane. The Cartesian plane is named after him, where the way we graph stuff on the X and the Y axis. But today we are going to do Descartes' rules of signs, which the guy was a real smarty pants. And he figured out a way to determine the number of positive and negative real zeros of a polynomial function. Well, how did he do that? He set up Descartes' rules of signs. The number of positive real zeros of a function either equals the number of variations in the sign of the non-zero coefficients of f of x, or that number less an even integer. All right, that's a lot of words, so let's talk about what it means, but let's get the second part too. More words. The number of negative real zeros of f either equals the number of variations in the sign of the non-zero coefficients of f of negative x, or else equals the number less an even integer. Oh, what? All right. What they're saying is the number of positive real zeros. By the way, let's just think about this for a second. We're talking about zeros, okay? This is how many times it's going to cross the x-axis, and the most that it could would be 7, because that is the degree of our polynomial. So the most zeros you could have are 7. And some are going to be positive and some are going to be negative. Or maybe not. Maybe there are none negatives. Maybe there are no positives. But we get an indicator by counting the change of signs, believe it or not. So my first term is positive 4x to the 7. My second term is negative. So I have one sign change from positive to negative. The next term down is positive. So that's 2 sign changes. The next term down is still positive. The next term down is negative, so that's 3 sign changes. And the last one is negative as well. So I had 3 sign changes from negative to positive. So this means I could have 3 positive zeros or count down by 2. 3 positive zeros or just 1 positive zero. Count down by 2s. Sorry for my bad handwriting with this pen, but it is what it is. All right, so Descartes said, count the number of sign changes, and that'll be your number of positive zeros, but it could be 3 or 1. You have to count down by 2. To find the number of negative sign changes, we're going to figure out what f of negative x is. And when you put in the opposite x, if you have an odd number exponent, odd exponent, the sign's going to change. So positive 4x to the 7th becomes negative 4x to the 7th. But if you have an even exponent, it'll stay the same. This will just be negative 2x to the 6th. Odd exponent, the positive 4x cubed will become negative 4x cubed. X squared, even exponent, this will stay the same, plus x squared. Minus 5 times minus x will be positive 5x, and then the coefficient at the end stays the same. So f of negative x becomes this polynomial function. Now let's count its sign changes. Negative, negative, no change. To negative, no change. To positive, that's 1 change. Stays positive. Back to negative, that was 2 changes. So you could have 2 or 0 negative zeros. Okay, 2 or 0 negative zeros. Now, let's just graph this real quick and let's see if all of this is holding true. So I said 3 or 1 positives and 2 or 0 negatives. All right, so let me switch over here to my, gotta find my, stop my share. Let's see if I can find my camera here. All right, there's my camera. Let me share my camera. And we want to put this in. All right, so what I said I was going to put in this thing that I was given 4x to the 7th minus 2x to the 6th plus 4x cubed plus x squared minus 5x minus 1. And let me just zoom to the standard window and see what I see here. Well, I'm not seeing much. Oh, okay, I'm seeing some things. All right, really, it looks like I've got a 7th degree equation. It looks like I've really only got a few little spots in here where I cross the x-axis. So I'm going to zoom in. I'm going to make my window a little bit smaller. I'm going to go from -5 to 5 on the x and from -5 to 5 on the y. And let's see what we get. Looks like I have one -1 and one +1. But no, you know what this -1 here is? Let's zoom in a little bit closer. Let's zoom, or let's go to, let's do -3 to 3, -3 to 3. All right, now let's see what that is. All right, so it touches there, which I'll have a multiplicity of 2. So I have 2 of the same negatives, but only have one +0. And that's what Descartes told me here. So that does fit what I've learned from Descartes here. So let me go back to share this. So Descartes' theorem said I could have 3 or 1 +0. We just had 1. Okay, we had 1 +0, we could tell. And 2 or 0 negatives. I had 2, but they were 2. It was 1 0 with multiplicity of 2. It touched it. And so that's how the 2, it was just 2 of the same one. All right, that's Descartes' rules of signs. All right, so now let's start putting these things together. Use the rational zeros theorem to find the potential rational zeros of a polynomial function. All right, remember, our keyword is Descartes. All right, this is a new and interesting thing. It says that if you have a long polynomial function where each coefficient is an integer, not a fraction, so all of these things in front are integers, not fractions, then P would be the factors of your very leading coefficient. Q would be the factor of, no, excuse me, I said that backwards. P is the factors of the constant at the end, and Q are the factors of the leading coefficient, and P divided by Q in lowest terms will be potential zeros. Potential zeros here. So let's just work this out. All right, I've got f of x equals 3x cubed plus 5x squared minus 8x minus 15. All right, so my p's will be the factors of -15, plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. The q's will be the factors of 3, plus or minus 1, and plus or minus 3. All right, now, real quick aside, what do you do if you don't remember how to get factors? I'll show you the way I used to get factors when I was younger. Factors of a big number. All right, let's take something, let's say maybe like 24. All right, let's get all the factors of 24. All right, and now we're going to take positive and negative factors. So it's plus or minus 1. This is your first one, times plus or minus 24. Those are factors, 1 and 24. Next number up, you could divide 24 by is 2. Plus or minus 2 goes into 24 12 times, so the 12 would go down here. Next one up would be 3 plus or minus 3. That will go into 24 8 times, plus or minus 8 over here. Next number up to try is 4. Plus or minus 4 goes into 24 plus or minus 6 times. And now we're about to run out of numbers to try. The only number between 4 and 6 to try is 5. And 24 is not divisible by 5. So here are all of my potential factors of 24. All right, now we had factors, our P, let's see, our P was negative 15 was our last value. And so the P's will be the possible factors of negative 15, which will be plus or minus 1. Which is plus or minus 15. 2 does not go into 15, but 3 does. Plus or minus 3 goes into it plus or minus 5 times. Only number in between those is 4, and 4 is not a factor of 15. And then our other value was positive 3, and the only factor is a positive 3 are plus or minus 1 and plus or minus 3. All right, so these are your P's, and these are your Q's, okay? And our potential factors are the P's divided by the Q's. So plus or minus 1 divided by plus or minus 1, which is just plus or minus 1, okay? Plus or minus 1 divided by plus or minus 3, that's plus or minus 1/3. All right, so we're done with all the ones up here. 3. Plus or minus 3 divided by plus or minus 1 is just plus or minus 3. Plus or minus 3 divided by plus or minus 3 is plus or minus 1, but I've already got that one written down. So finish with the 3's. Now let's do the 5's. Plus or minus 5 divided by plus or minus 1 is plus or minus 5. Plus or minus 5 divided by plus or minus 3 is plus or minus 5/3. Plus or minus 15 divided by plus or minus 1 is plus or minus 15. And then plus or minus 15 divided by plus or minus 3 is plus or minus 5. And I already have that down. And so these then are my potential zeros, my potential zeros. All right. Now, my original function was x equals 3x cubed plus 5x squared minus 8x minus 15. According to Descartes' rules of signs, then I have possibly one, just really only one positive zero. There's only one sign change, so I have I have one positive zero. The most zeros I could have are 3. F of negative x would be, all right, negative x cubed would change the sign, so that'd be negative 3x cubed, but negative x squared would not change the sign, so that's still 5x squared. Negative x times negative 8 would be positive 8x minus 15. Now how many sign changes do I have? I have 1, 2 sign changes. So I have 2 or 0 negative real zeros. Okay. And that would give me my 3. All right. Now, if you wanted to keep finding these guys, you could find your potential zeros by substituting it, right? Substituting it. All right, and we're going to do that one with the new problem, actually. So we won't do that with this one. Let's go back to our PowerPoint slides. Let's do that one with this new problem. F of x equals 3x cubed minus 5x squared minus 4x plus 4. All right, let's apply everything that we've been doing to it now. Okay, stop this real quick and write this one down in your notes. Pause it and write this one down in your notes. All right, I've got mine written down. Our job is to find all the real zeros and write it in factored form. Okay. Now, a couple things that we want to just notice right out. The most zeros we could have are 3. Okay. And according to Descartes' rules of signs, I've got a positive to a negative. That's one change. Stays negative, changes to positive. That's 2 or 0 positive zeros. Okay. And then let's figure out f of negative x. That's going to be negative 3x cubed minus 5x squared plus 4x plus 4. And so only one possible negative, only one negative 0. All right, so then let's use, this is the factors of 3 are q values, the factor of 4s are p values. So the factors of 4 is just plus or minus 1, plus or minus 2, and plus or minus 4. And the factors of 3 are plus or minus 1 and plus or minus 3. So then our p's divided by q's, which are our potential factors, our potential zeros, basically, is going to be 1 over 1 is 1. 1 over 3 is 1/3. 2 over 1 is 2. 2 over 3 is 2/3. 4 over 1 is 4. And 4 over 3 is 4/3. All righty. Now we need to find the zeros. All right. And probably the best way is just to start plugging these guys into the original function. This is our original function that we're working with. Plug them in until you get 0 as a remainder. Okay. So I'm going to start with positive 1. Okay. 3 times positive 1 to the 3rd power minus 5 times 1 squared minus 4 times 1 plus 4. Oh, so positive 1 is not a 0. Let's try negative 1. And you can put the second entry will open up to your last thing. Second entry will be the last thing you entered. And then we can put just negative 1. Oh, that's going to mess me up. All right, so negative 3 to the negative 1 to the 3rd power. And then it was minus 5 times negative 1 squared minus 4 times negative 1 plus 4. 4 plus 4. All right, let's press that one. Ah, there's my first 0. Negative 1. I got a remainder of 0. So my first 0 is x equals negative 1. Once you find the first 0, we can do something called synthetic division. Synthetic division. Maybe you've done it before. Let me show you synthetic division real quick. Write down the coefficients here of your original guy. 3, negative 5, negative 4, and 4. And I forgot to finish the video. I think I thought I had paused it, but I didn't pause it, and probably thought I had finished it. But when I started trying to finish it, I'd actually paused it. But anyway, here we are. We had gotten this far, and I did not finish the synthetic division. All right, so look over here at my thing. Let me show you how you finish synthetic division. Okay, you pull down the first number. 3 times negative 1 is negative 3. You add them up. Negative 8. Negative 8 times negative 1 is not positive 8. Add them up. You get positive 4. Positive 4 times negative 1 is negative 4. Add them up and you get 0. This would be the remainder. And you get a remainder of 0 because negative 1 was a factor. So we factored it now with an x minus -1 or x plus 1. And what's left is this. So that's your remainder, 0. That's your constant, your x term, and your x squared term. So 3x squared minus 8x plus 4. Okay. All right, now we need to finish factoring. We need to find our other ones. You could factor, you could use the quadratic formula. Maybe the quadratic formula would be the easiest. So we already know that x equal to -1 is one of our zeros. Let's put it in the quadratic formula. X equals -b, -8, plus or minus square root, b squared, minus 4 times a times c, all over 2 times a, which is the 3. And if we simplify this down, we're going to get 8 plus or minus square root of 64 minus 48. 64 minus 48. All right, that's the square root of 16 all over 6. So we end up with 8 plus or minus square root of 16 is 4 all over 6. So this is 2 answers. This is 8 plus 4, which is 12 over 6, which is 2. And 8 minus 4, which is 4 over 6, which reduces to 2/3. So these are our other zeros. We found all 3 of our zeros. Okay, hope that was helpful.